Hey guys, welcome. This is the Oracle Autonomous Database Learning Lounge. I'm Marcos Anasivia, part of the product management team for Autonomous Database. And today we have a very, very cool session on, well, how to work with JSON documents, but also using the MongoDB API in Autonomous Database, okay? So it's going to be a very, very cool session, especially for developers out there, right? So for the agenda today, we're going to have Beda Hammerschmidt. He's a vice president on the product development side. And also Hermann Baer, he's Senior Director of Product Management. And they will introduce the MongoDB API for Oracle Database, talk to you guys about what are the industry, terms nowadays, document, store, right? But also show you guys how that actually ties into the Oracle Autonomous Database, right? And the database in particular. And also, show you guys how to use the MongoDB APIs against the Autonomous Database directly, right? So you're developing, but also on the most secure database, right? And without any problems using SQL and NoSQL, right? So being able to join those two worlds, right? So before we begin, make sure when you guys have questions to type them into the Q&A section of Zoom. And we're going to share with you guys some links. So when we share the links, they're going to go through the chat, okay? And we're going to make sure to post the recording of this session as well in our bit.ly/adbll-main blog. And then you're going to also see it in Ask Tom, for example. Okay. All right. So before we start, a few important links for you guys to bookmark. So basically these links, I'm going to put them right now in chat just so you guys have them. And basically, we have a new page called the Get Started with Autonomous page. So please make sure to visit and take a look. We have lots of goodies in that page for you guys, okay? All right, and without further ado, I'm going to pass the ball to Hermann and Beda. Thank you guys very much for joining us today, this morning. I'll stop sharing my screen. I'll let you guys share your screen. And again, take it away. Thank you.
Thanks again for the intro. Marcos, and thanks for all of you to join today. My name is Hermann Baer, and I'm here with Beda Hammerschmidt and a lot of other very capable folks on the QA to talk with you folks about what we're doing in the Autonomous Database to actually natively support JSON and provide not only JSON, but also pure document store capabilities with the MongoDB API. While I'm going to do the majority of the presentation, I will always rely on Beda, who's the vice president running the development, to actually keep me honest and to chime in. We have this running joke. We will see at the end of the presentation how much time he actually hijacked from me. With that said, let's just start, right? It's why store JSON, right? I think given the fact that you folks are on this call, you folks have heard about JSON or are interested in JSON or have actually done something with JSON before. Why are people actually interested in JSON? It's very simple. There's a couple of benefits that are actually coming from a JSON format, right? It starts with the fact that it is actually a self-describing schema, flexible and easy way to model business data. As you see on the very left-hand side, right, this is a simple document describing movies where we have, when you look at it, we have different data types, right? We have a title, we have a date, but we also have more complex structures right within the document itself, because obviously, right, a movie has more than one actor, a movie has potentially more than one producer, more than one genre, and so forth. So it's very easy to model the schema itself in the data, and it's human readable, right? Now, when you look at that and look at the applications that are actually working with the data, you see that there is very, very little impedance mismatch between how you model the data, what is on the very left-hand side, and how you actually use the data in your application. Like you see the sample class movie that you would use in a Java application, and you see it directly reflects the structure of of your document, right? We have a list value, for example, for the cast, right? And we have all the other attributes modeled directly. And last but not least, and that is something we see sometimes customers actually starting using the Autonomous Database without knowing that they're using a relational database under the covers, is that it's very easy to actually work with the data with a CRUD model. Like you see at the right-hand side, there's a customer's find, and all you're saying is, okay, you want to say, what's the last name of it? Or, you're looking for a movie title and whatever. And if you compare that with what you potentially have to do if you're doing it in a purely relational world, which is shown below, it's you have to construct a SQL statement with selects, from, where clauses, bind variables, and so forth. So there is, just from an application development perspective, it's a very simple and elegant model of actually working with your documents, working with the data as it is. So what is Oracle doing in this space? Oracle's vision and Oracle's development goal is to provide a converged database architecture. So our goal, our vision is we have a single database architecture for any data type, any kind of workload in your system, as compared to single-purpose databases. So when we talk about JSON specifically, right, for us, JSON is just another database type, just another way of interacting and working with the data within the Oracle ecosystems, as compared to a single-purpose database that was built for one thing and one thing only. Like, when you look at the right-hand side, if you were trying to use something that goes beyond the document, like analytics, or you want to do some graph analysis, or even, God forbid, some analytics, you're probably running into the limitations of the single-purpose database. And besides the single-purpose build, what we have seen over the years is that database models and themes and the new sexy thing, it comes and goes, right? It's like in the early 80s, right? The object store databases declared the death of the relational model, right? There was, and there's probably names on it which some of you have never heard in your life, that were declaring the new next single-purpose thing of how to solve actually data management and data persistence. Our approach at Oracle was from day one to actually embed whatever multimodal, whatever data type, whatever workload comes up, to subsume that in the Oracle database itself, right? So the Converged database is not a new theme, a new topic. We actually do that since the very, very early days of Oracle. So we saw object types come and go, and with the single-purpose databases, we saw XML coming, we saw JSON coming, graph coming, and now the next DB is, if this slide is going to be shown in 6 months from now, right, there might be vectors written on the future, right? So it's going to continue, and in 10 years from now, who knows how the slide looks like, but the Oracle multi-model model will continue on the bottom of it. And looking at the specialized databases, I touched on that briefly before. If you build something for a single purpose only, right, it's difficult to apply other workload types or other use cases to it, right? Like if you talk with and now we're talking about JSON and MongoDB specifically as the most prominent document database, it's difficult to combine, your JSON workload and data type with anything that is not JSON. So you have to reach a point where you hit the ceiling with your system, or you have to really start to become very creative in trying to solve your business requirements. And I will highlight a customer later on that was actually running exactly into that. So with that said, coming back to Oracle and the Converged database, our vision is really, we want to bridge the gap between the JSON and the relational world. So it's the data is your asset, right? That's what counts in the database, right? So we want to enable you to work with your data with whatever is the best possible form for your business requirements. So The data is center, and if someone wants to work with it from a document store perspective, where everything looks like a document, like an object, sure, you can do it. And if there's the more classical world, where potentially tapping into analytics, where everything should look like rows and columns, you can do that. And you always work against the exactly same data set. So there is no replication redundancy of the data required to actually achieve that goal. So it's really, think of it, and you will see that later on, it's really with what we're doing here with the JSON support, and specifically with the MongoDB API that we added to the Oracle database. We give you to look at the single center data with whatever form is better to you, right? Whether this is a standard Oracle client, JDBC, SQL CL, any kind of OCI interface, you work with it from a relational perspective. Or if you use any kind of Mongo client or tool, you use the Mongo driver and you work with it without the tool or the driver even knowing that it's not a Mongo database. The Oracle database has a specific JSON development IDE built, so you can use that in the Oracle Cloud tools, just as you use MongoDB Compass or other tools, right? Like use the VS Code MongoDB plugin to work against the Oracle database. I will briefly show that later on as well. So it's really, the data is center of everything, and you work with the data, whatever interface is the best for you. Now, one of the questions that comes up obviously is this, oh, yeah, we know Oracle. Oracle is around. Oracle is a relational database. So how do you make it a native document store? Because ultimately the goal here is really to enable you to use whatever MongoDB skills or benefits are there from the APIs or integration in frameworks, to use that against the Oracle database, but to enhance what you can do with the data. So what is Oracle doing to be a native document store? Well, guess what? This is what we're starting off with. This is what everybody knows from an Oracle perspective, right? We have a relational model with schemas, with tables. The table has rows, everything is flat, and everything is structured. So what we're doing is the MongoDB API is a smart piece of the Oracle database running in Oracle REST data services that intercepts the MongoDB wire protocol and translates this into something that the Oracle database understands. So it is really the MongoDB applications. You use the same skill sets, tools, frameworks. You work against this API, and we take care of the rest, translating this into something that the Oracle database works with, which integrates it into the overall Oracle ecosystem. So how do we bridge the gap, right? I showed you the relational world before, and this is how the world looks in a Mongo world, right? We have JSON collections. A document is just a JSON value, right, with the flexible structure as we have seen before. A collection contains a set of documents, and a database contains collections, right? So this is the model of how a MongoDB actually works from a data persistence perspective. So I said we're intercepting the wire protocol. So now let's look into that, what we are doing when we actually do this interception and conversion into something that Oracle does, right? So conceptually, whenever you talk about a database in a Mongo world, right, we are mapping that in the Oracle database to a schema. So a database is just a logical container of a bunch of collections that deal a specific purpose, right? Which is, when you look at it from the classical Oracle way, this is a schema that is implemented in an Oracle database. So a Mongo database is mapped to a schema in the Oracle world. A collection, right, is just a bunch of things. Well, guess what? In the relational world, this is a table, right? So a collection is just an abstraction over a specific defined table, right? So we're using tables in the Oracle system to store collections. And the table is basically a bunch of control columns plus one big JSON data type field which contains your collections, your documents. So when you say create collection here, right, we are under the covers, create a table movies, and we have the control columns plus the big JSON object. And you probably can guess what comes next, right? If you insert a document into a collection, this is translated into inserting a row in the Oracle database. And a filter, if you say something like, I want to see all the movies that have a title of Iron Man, right? We translate that as part of the interception protocol into SQL, which also enables us, the moment we're getting into SQL, we leverage whatever the Oracle optimizer does for working with data. So when we get to that point, right, I hope I was able to show you how we actually transparently implement a pure document store framework with the Oracle database. One question that comes sometimes is, yeah, but it's plugged onto the Oracle database, right? It's still the relational database. Yes, that's right. But when we talk about working specifically with JSON documents, the secret sauce, beside actually being able to work smartly on whatever is thrown at the database, is the storage itself. So what we did at Oracle, we implemented a specific native data type, binary data type in the Oracle database. It looks like this, right? It's in the Autonomous Database. You will see that we haven't exposed the JSON data type per se, which was just a matter of, are we allowed to backport all the things? But it's exactly the same functionality of the binary JSON format, the optimized binary JSON format that we have in the Oracle database. So in the Autonomous Database, you will see what you see on the left-hand side here, where it is basically the format is plunged into the check constraint, whereas beginning with 21C and 23C, we have exposed it as a native data type. And there's a couple of benefits that come with the native data type, right? It is with a binary JSON format, we all of a sudden have extended types. When you look at what JSON itself provides, right? JSON has a very, very small set of standard data types, which aren't necessarily reflecting what you're dealing with in a database, right? With the binary JSON format, we're getting an extended data type system to really map what you're working on. It's also the format was specifically developed for very fast path evaluation and efficient random access. There's a full integration into also the driver framework. We have partial update capabilities. We don't have the time to go into all these details today, but for all of you that are interested in it, we are basically expose everything what we're doing in a JSON data type, and also comparisons against, standard text or the BSON format that Mongo has in a VLDB paper, which is accessible for all of you. So the link will be on the slides. And actually, we looked at the binary JSON format of Mongo as well, but decided, we can do better than that. So it's really, when we talk about JSON documents, it's a native binary format in the Oracle database, specifically purpose-built for dealing with document stores. Okay, so it wouldn't be a converged database if we weren't talking about SQL, the core foundation of the Oracle database, right? Which we do for a couple of days right now. So with the document store API and storing the things as a relational table underneath with the optimized format, right? We're still preserving what the Oracle database is really good at. And this is where the power of SQL meets the schema flexibility of the JSON storage. And what we're doing here is we briefly talked about the native data type, which is the core foundation for really fast access and processing of the data. But we also integrated it into the SQL ecosystem that we have a very simple way to use a simple dot notation for SQL access. You will see that in a second. To really work with the JSON attributes, just like you work with columns. We also spend a lot of time since version 12.1 beta, 12.102, I think. The ANSI standard, we started building SQL JSON operators.
Yeah, it's 12.102, but the standard was published after the product was out, basically.
So we were driving a lot of the standard. and integrate it in a way that you can transparently interchange between JSON and relational. And just one word here, right? Our philosophy here is really open standard, right? Whatever we build, starting with 12.102, we submit it to the standard, we work with the ISO standard to actually make this a functionality that is clearly defined, clearly documented, and can be leveraged by every database vendor out there, because we believe that the transparency and the interchangeability here comes more from an open standards than from an open source perspective, where it's kind of nice having an open source database with a very proprietary language like Postgres had it at the very beginning, and then no one else can use it anywhere else.
You allow me to say something, Hermann, like what we put a lot of emphasis on is that the concepts are apply for all operators. So for example, we have JSON path expression. I think Hermann will show them later. And they have the same semantics regardless of what operator you use it, which really makes it, you learn it once and then you apply it many times. The interesting thing is, like, we put a lot of emphasis on these operators. We added them to the standard. And we see other vendors like Postgres, MySQL, SAP HANA, etc., abandon their own proprietary enhancements and basically converge on the standard we wrote. So Oracle users get these things first, and that's really a benefit of using Oracle versus competing products. Yeah, back to you.
Thanks, Beda. Yeah, please chime in whenever you have something to say. Okay, I think I've said enough. Let's probably shift gears for a second and look at what I was talking about. So what I'm connecting to the Oracle Cloud Infrastructure. As you can see, it's safe and secure as long as you find your phone to press the button. And what you're seeing here is an autonomous database, specifically an autonomous JSON database, which was purpose-built as a document store service offering. And what you get here out of the box with the autonomous database is you get the MongoDB API as part of the fully managed service. And I could copy that here, but you just focus on it, right? I always call this my Gaga database, right? So it's the Gaga HAD database, right? And with this connect string, I can actually work against the database like I work against a MongoDB system. And let's just do that. Okay, I'm setting an environment variable that actually points to my Gaga database. You see that? It's the same database. I just basically made my life easy here to provide that information. And what I'm doing right now is I'm using a Mongo tool, and it seems they have to do something in their code. So this is Mongo world, right? So this is the Mongo shell downloaded, in that case, through Brew. And I'm in the Mongo shell, and Mongo shell doesn't know that it does work against an Oracle database, right? So if we were to
and Mongo shell is just one example of a MongoDB tool. You could have used Compass or Mongo import, Mongo export, the Mongo driver for Spring, or whatever tool is out there for MongoDB. And the connect string is kind of like the one you would connect to Atlas or an on-premise MongoDB, but all you do is point it at an Oracle database with a Mongo API. And
you're about 23 seconds ahead, Beda, because I can do exactly the same.
No, sorry.
No, it's all good, right? There's nothing to hide, and you're absolutely right? So you see my Gaga database again, right? So I can use the Mongo tool, and you see within this is the database user that I connected with. It's a user JSON. I just like JSON, right? At the very early days, when we introduced JSON, there were a lot of people that actually were writing JSON as the name JSON, and I just got stuck with it. Or, if you really want to go that way, right, you can actually also, have visual code, and we connect to, this is the Mongo plugin, right? You see here the JSON data type, and you see in that case that the same demo stuff, the demo collection that we have. And last but not least, come on, before Beda says, we have a cloud-based JSON IDE, let's just, close the loop here as well. And look at the JSON IDE too, right? So this is the stuff. You see the same. I'm not going to do anything with that. I'm just dropping it. Okay. Minor digression, going back to the Mongo shell, right? Because we are not in an Oracle world, right? And when you're here, you saw I dropped the cars workshop. I can now just use Mongo like I'm using Mongo, right? I'm inserting a document into a non-existing collection. Okay, insert one, that is fine, but you now see the collection is there. And if I were to look into Oracle, you will see the same collection is here, right? But it's probably a little bit too much to trying to add a lot of documents here manually. So let's just use another tool, Mongo. I'm using Mongo import here to actually import a little bit more data set that may make it a little bit more fun here. So I'm now loaded around 3,800 documents, as you can see, if I'm going back to my Mongo shell. This is all Mongo world, right? And the tools, they don't know anything about the fact that it is an Oracle database behind it, right? You see documents. Oops. It has a point. Okay, so we see we have the movies collection, and I can now actually just add some data here, just like I did it. Yeah, like I did my simple hello world. So I'm just adding quickly 2 new records, and I'm adding that just because, there's too much other data in there. Okay, so I now added 2 movies for the year 2023, right? So I added a Super Action Mars and a Fast X movie, right? So we see those here. If I were to do that in the Oracle world and do the same, you will obviously see the same data. You see the Super Action Mars and the Fast X. Let's now just quickly, just for the heck of it, connect to the same database with SQL. And all I want to do here is I want to quickly update that record, in that case using SQL in a normal client server connection. That means when I'm updating it here, you will expect it still to be exactly the same as it was, right? Because that's the transaction consistency that you get from the Oracle database. You would have exactly the same behavior if you had updated it with a MongoDB API, right? You will see it, okay, if I'm doing here as well. Now I'm actually more pushing my typing skills than anything else. You see the 2 things, right? And the moment you do a commit, stuff is in there, and you will see that my Super Action Mouse movie is gone from the system. This is very important, right? That's the integration that we are actually providing inside the database, working with this converged model, right? It's not like, if you have for example, if you use a MongoDB with a lot of shards, right? You have to decide whether you go for speed versus consistency, right? You can have the eventual consistency model where not all shards are necessarily updated at the same point in time. But now let's switch gears and look a little bit more into actually I have it already open. Let's just into the SQL world of things of how we did that, right? of how things look like, right? So it is, I said that it is a special table with basically the main content in the data JSON type. So see, these are the control columns. And I can look into that data with SQL, right? So what you're seeing here is, if I'm just opening a sample document, is that font size big enough for you guys, or I can actually make it a little bit bigger?
Oh, that's fine, I think.
Okay, cool.
I can
So you
read
see,
it.
this is the JSON documents that we have seen in MongoDB Compass, that we have seen in Visual Code, that we have seen in any kind of MongoDB API or driver. And now the fun stuff starts. I talked about the fact that if you have a single purpose database, you have a little bit of an issue, you know, doing something that is outside the scope of that system. So let's now just start working with the data purely relational. And what you're seeing here is the simple, what we call the simple dot notation, to look into attributes of the JSON document. And it's basically, when you just look at this, the m.data.title is the scalar attribute title in my document. And data.year is the scalar attribute year in it, right? So if I'm just running this, you will all of a sudden get a relational representation of your data, right? It's the same data that you're working with. It's just relational, right? And as you can guess, you can start doing really cool things with it. Like this is, you know, from a SQL perspective, a reasonable simple statement where I'm just aggregating the revenue for individual years and then build a ratio to report calculation to see, okay, what's the ratio of a given year since 2018 that contributed to the overall revenue that I made, right? So this is very simple, very elegant. You see, right, those were the two years that we added, right, the 2023 and the super action Mars that we updated. And you see that COVID hit us a little bit. So this is real data coming that we're dealing with. Try to do that with a pure document store database, right? It is very, very hard to actually accomplish that. We talked about the operators. So let me just show you a couple of operators that we have built in the Oracle database, which are all part of the ANSI standard. So this is one of the most simple ones, JSON value, which is, as the name says, extracts values out of a document. You have also the choice here, you know, you define the returning set, and you can define how you actually deal with documents that don't have that attribute, right? You could raise an error, right? If you're having a schema enforcement, or in that case, we are just going to go and return none, right? So if you go down there, right, everything which doesn't have this attribute specified would get a none returned. And the same way you're working with it is you can obviously just build a simple view on top of it, right? So that is a view which has a little bit more of a construct, a JSON table, which actually basically decomposes the JSON attributes and would actually unfold it, unnest it if the view had an array defined in it. I will come to that in a second. That's fine, right? So now I have a view created, right? And what you're doing is you're just working with it like with a relational model, and people don't even know that it is potentially a document underneath it, right? And let's just do, and this is just, you know, to avoid me doing any typos. So if I would look for in this movie view for a specific movie with a specific title, it all works, right? And what you see here is, and that is why I'm getting to it, I briefly touched on it, is that view I intentionally put in an array, a structure that has more than one value in it to to represent that in a relational view. And what you can do, and this is actually what you would normally do, is you unnest that information. So I'm now looking at this Iron Man movie, and what I'm doing with the JSON table here is I'm unnesting the cast column, which is represented as the actors thing. So now you will see all of a sudden, right, for a single movie, you know, an entry for every actor that actually played in that movie, right? You will see even Larry Ellison actually made it into IMDb as an actor for that movie. And this is actually where it really becomes interesting. For those of you who deal with document stores, you will have heard that the paradigm of how do I define my documents is you define your documents in the form that your application is using it. And you have seen it, I brushed over that, but the movies, the document structure was always that the main driver of a movie is actually the movie itself, right? It's a title, a summary, and everything else is hierarchically plunged underneath the document. So, but now, what is if you all of a sudden want to work with this data in a different way? Let's say, right, we want to actually look into it from an actor perspective, and we want to see, you know, how successful is an actor, how many movies did an actor do, right? You're in the pure document world, it becomes a little bit interesting, right? Because it's not how your documents are organized, right? So you either start replicating it if you want to do it, or you start building complex aggregation pipelines in any way, shape, or form. With SQL, it's very easy. So what I'm doing here is I'm basically just pivoting the information in my hierarchical movie title driven documents and show them, you know, driven by the information of an actor. And all of a sudden you will see there's an actor, Stan Lee, who's in 25 movies and, you know, had an insane number of revenue generated with the movies that he was actually part of, right? So this is the power and the flexibility to just go and work with the data in any way, shape, or form as how you want to actually work with it, right? And I said at the beginning that, you know, you can actually interchangeably work with relational and a JSON representation. So at the moment, what you see at the bottom, this is a relational representation, but we can easily go ahead and actually JSONize that information. So now what you're seeing here is I'm basically just wrapped it into a JSON object, and the information that you have seen before, that our Stan Lee was in 25 movies with an insane amount of revenue generated, it's now a JSON object that you can work with. And without going too deep in it, right, I can actually, if I wanted to, I could create a new collection out of that. So what I did here is I basically created a new collection, which is called, where is it, actors. So now if I'm looking into the actors collection, okay, I have to go over to into the JSON IDE. You see, we created a new collection where we actually pivoted the information. And if you go to any kind of other tool, Mongo Shell was the first one. So you see the information that we created. Okay, probably going back to the slides, and I still remember the one question. So I hope I was able to give you a quick run through that with the Converged database and working with JSON documents. It doesn't really matter whether you're actually working with documents or relational. You use JSON collection document APIs for the simple, flexible persistence when you need it, or you use SQL JSON for any kind of what we did in that case for analytical capabilities, right? It's really, there's no boundary. And if we wanted to, right, if we had more time, right, we could run a machine learning model against the JSON data, or, you know, use the graph or the spatial capabilities within the Converged database to work with the same objects. Don't want to spend too much time on that slide. You will get it in the handout. There's nothing, right? When we look at the JSON database, the Autonomous JSON database, or the Autonomous database in general, because the capabilities of the MongoDB API are in every flavor, there's nothing to be ashamed of, right? We are able to store larger documents. We have deeper depth of nest documents, right? From an indexing perspective, transaction perspective. There's nothing to be that actually limits us for using that as an enterprise-grade document store API. Now, to the question, there was the question before, okay, what is the level of compatibility? We have migrated quite a number of applications where there was no to minimal code changes, right? It's like what we have done in our simple example here. We just connected to the Oracle database with tools and worked with the document store inside the database, where we have a couple of slightly different behavior and currently limitations is when it comes to security and indexes and the aggregation pipeline. So the security model, I mentioned it at the beginning. We don't have we have the concept of schemas in the database that represent a database in the Mongo world, right? So we consciously decided to integrate into Oracle's existing database authentication and authorization model, as compared to, you know, building something new where you have users and databases like you have it in the Mongo world. Because from a converged database perspective, this is what we believe is what you need to really get this unified user management and enterprise-ready behavior of your data management system, the Oracle database here, right? It's, as of today, a limitation that we're having in the Autonomous database, or it's tied to the database releases 19c and 21c, is we do not support the create index command in the MongoDB API. You have to create indexes in SQL, right? That's just an implementation. You probably don't create indexes all the time in your application. So this is a initial setup. This is addressed in the Oracle database 23c, right? So the moment 23c will hit Autonomous, and we will talk again here in the database launch, you will see that running against the Autonomous database. And the same is true for the aggregation pipeline, which is currently not supported in 19c and 21c, but we have all the cookbooks. We know exactly how to do everything of that in SQL, because that's ultimately what we're doing when the aggregation pipeline.
Before you move on to the next slide for a second, on this indexing stuff, so we said it's addressed in 23c, that's correct. One observation is that MongoDB, in order to improve the performance, you can throw more nodes at it, called sharding, or you add indexes. Oracle has way more features to tune the performance, and one of them, for example, is Exadata. So if you run on Autonomous database, or if you use Autonomous JSON database and you have like some filter expressions, they usually get pushed down to the storage cell. So you get very good performance even without an index. So it's generally, I would say, recommended that you not blindly translate every MongoDB index to a Oracle index, because it may not be needed. So this is where you just get a better performance out of the box. And the other difference that is not shown here, or limitation that is not shown, is really the security model. So MongoDB has a different security model in terms of roles and users. And there we just think it is much easier for a DBA to only maintain one security models, and where all the security features, encryption, apply holistically over the whole database. So this is technically a limitation. It was never an issue in the many migrations we did. And actually DBAs like this fact that they say, oh, I don't have to like secure another database. understand other security models, etc. It basically behaves like everything else in Oracle from a security standpoint. Back to you, Hermann.
Thanks, Beda. Yeah, as said, right, it's coming. It's already there. This is a live screenshot of a 23C database. And as you can see, we are translating the aggregation pipeline steps, which is a sequence of specific operators, aggregators, and accumulators into one SQL statement. And that actually gives Oracle the capabilities to really streamline the processing and to improve the performance, right? Beda talked about what we're doing physically with Exadata. But there's also, you know, quite some smartness in the optimizer, right? You can get, if you get the order of the aggregators or accumulators wrong, you can have a detrimental impact on the performance. It's also just a teaser, right? We will talk about that in the context of Autonomous Database next year. Is what I showed to you when I basically pivoted the database is what you can do much better with JSON duality views in a later release. We generally believe that with Oracle, you get more than what you get with a MongoDB, and because we have the native support for document store workloads. And that is built on all the functionality of the Oracle Converged database, which is, well, the enterprise-grade Oracle database that you all probably know and use, right? So it's really a staggered thing of, and you have seen it, right? We were using SQL against our documents, but you could also use everything else that is in the Converged database to actually work against your document store data that is stored. And Beda touched on some of these things already. It's specifically when you talk about the enterprise-grade Oracle database, you get this enterprise mission critical support with everything, right? I showed you just atomic transactions, right? You would see everything that you're using coming from a high availability perspective or a security perspective. It's the same database. It's whether you use DataGuard or anything like that, it just works. It's a native data type in the database, and everything that is there for performance and tuning perspective, and Beda touched on Exadata, is there and readily usable with your documents, plus, you know, all the cross-functional thing. And there's one more thing, right? It's not only built on the enterprise-grade Oracle database, but it is part of a fully managed autonomous database, right? It's I mentioned the Autonomous JSON database before, which is a purpose-built flavor service of the Autonomous database, specifically targeted towards the document store. So whatever you get from the Autonomous database, with Autonomous JSON database, you have it purpose-built for a document store. And when you look at it from a pricing perspective and performance perspective, we are very competitive as compared to MongoDB Atlas, right? So this is just a simple configuration of an 8.0 CPU system where we priced Mongo in AWS against the Autonomous JSON database, right? And our costs are way below that of Mongo. I was talking about Autonomous JSON database quite a bit. This is one of the services within the Autonomous database family. And it is purpose-built for document store, but it is basically a subset of the functionality what we have in the Autonomous transaction processing functionality, where we are just basically limiting your storage of non-document data, pure relational data within the HAD framework. Okay. So just one or two things about, you know, has this been done before? What are customers actually doing here? The stuff that we talked about and the benefits of the Converged database is actually not something that we made up with, but this is something people really benefit from. So there's one customer, Proofpoint Decimal Point Analytics, who initially ran on AWS with a MySQL and MongoDB ecosystem. They needed the relational consistency through the MySQL. They're dealing with their financial services provider. They needed the relational consistency for their financial data coming from all the systems. But the end user system required or wanted to have MongoDB documents as an interface to the end user. And they were struggling with this model where to get the relational consistency and the MongoDB document store view of the world, they ended up with a complex architecture with multiple databases, with data replication, which was very complex and error-prone. We worked with that customer. We migrated them to a single autonomous transaction processing system and basically removed the complete man in the middle, the replication. We are working with one database, one source of truth, providing both the relational and the document store capabilities. We have other customers that started off working against, the managed database without even knowing that it is a relational system, right? Infstones started to develop with MongoDB API drivers, Google Go. When we talked with them for the first time and threw out database lingo, they didn't even know what we were talking about because they were not aware of what they're working against, which was pretty funny. And we're eating our own dog food, right? The Oracle Backup Service, it's an internal system that backs up centrally all corporate laptops worldwide, is built on the MongoDB API with Java Micronaut. So it is really providing the JSON capabilities and document store capabilities in the database helps you to reduce cost and risk and to simplify your work, right? You're storing and using data, whether it's relational or JSON documents, in a single converged database, which provides you unified management, security, and consistency. And then, actually you use whatever interface, whatever API is best for the job, whether this is relational and document store, right? And if you actually want to tell upper management, this is the executive summary, right? Reduce cost and risk, simplify your world. There is no reason to use a different database management system than Oracle if you have these needs. Okay, when you get the slides, there's a couple of pointers for more information, including live labs where you can actually work with the functionality similar to what I have shown you today. Yourself, right? Live labs, it's free. You just connect to it. You can even spin off a sandbox environment and just play with it, or use your free OCI tenancy to accomplish the same. With that said, thank you for your time. I think I have about 23 seconds left.
Thank you.
Whatever overflow time we're having, back to you, Marcus.
Thank you very much. Really appreciate it. So thank you very much, Hermann. That was great. Thank you, Beda. And I'll let you guys start answering the questions we had in the Q&A. So please, guys, go ahead.
So we got through all of the Q&A. Marcus, there was nothing outstanding?
No,
there was
a
question on pain points, but I think you addressed it. It's really about simplifying complex architectures. That if you run multiple database and you shovel data around and you have like messaging buses in between, etc., that there is no need to do that. You can run these JSON workloads in Oracle, and even better with the MongoDB API, your developers even think they're working with a MongoDB and can continue to use their skills and tools and feel right at home.
Okay.
Yeah.
Right, and I see there's and actually I saw someone curious about the tool you were using to copy paste code.
Oh,
Flippy, yeah, I put the URL in there. Yeah.
Flippy,
okay,
yes.
awesome.
Yes. This is
okay,
just,
that's
as you have seen when I was doing the live typing, right? It's there's always room for errors. So
no, that's great. That's great.
Julian and Josh and co are very busy on the chat. By the way, are there any questions that we should point out here, should discuss verbally at that point?
Yeah, we got an interesting one.
Okay.
Just asked that the question is, if we're using a MongoDB tool to work with ADB, the Autonomous Database, how will it work with ACID? How do you make commits? I think that's a good question. So the Mongo API, the Mongo programs support creating a transaction, committing it, and rolling it back. Not too different than it would be for like a SQL program. And so even with real MongoDB now, they have a lot of restrictions on them. You can start a transaction, do some operations, and commit it. I think a key point here that it's often overlooked, though, is even when you're not starting transactions on your own, By default in Oracle, we're using read committed consistency. So when you execute a query, even through the Mongo API, the result you get back is consistent at the point in time that the query was executed. So you get results for your query that actually existed in the database at the same time together. This is not the case by default with MongoDB. So when you execute a query, they don't have this read committed consistency. And so if concurrent inserts or updates are going on while you're executing the query, you can actually get a result back for your query, your query that, results that didn't even exist in the database together at the same time. And you can get weird stuff happening, like the same document being returned twice. These are kind of cases that, you might do your testing and, kind of things that, that might not, be discovered until you get to production. So we support ACID and we support read committed consistency and durable rights, and we still provide competitive performance.
Thanks, Josh. Yeah, as said, right, we work with SQL and the JSON collection information against the same data set, interchangeably controlled with the same ACID framework, the recommitted that Josh just was explaining in a very detailed and great manner.
We've got a couple more good questions here,
okay.
Kind of on the topic that you're talking about. So the first question is, are there any tools for migrating MongoDB applications to ADB? There's some features like pipelines in MongoDB that don't have an equivalent. How do we handle those scenarios? And so we do support the aggregation framework in 23C, but Autonomous Database is still on 19C. So this question is still valid, right? How do we, if the MongoDB application is using the aggregation framework, how would you migrate that to 19C? And so right now the answer for 19 is that you have to convert them to SQL. So SQL can do anything that the aggregation framework can do. It's just a little bit of upfront cost to rewrite those queries. And if there's any tools, yes, you can actually use MongoDB's own tools like Mongo import, Mongo export to move your data from one database to the other. And we even have this product called Golden Gate that will allow you to do a live migration to the Autonomous Database. It'll actually read the data as it changes on your MongoDB instance and mirror that data in the Autonomous Database. So you can have the two databases in sync and then migrate your application to. And so the next question is, if each microservice uses MongoDB and Mongo Atlas, can the customer use a single instance of AJD for all their microservices, or do they need multiple instances? So Herman, you might be better for this question.
Well, I think that is one of these answers. It depends is the short answer, right? It's from a pure horsepower perspective, there's no reason to have multiple AJDs, for hosting multiple microservices. It is very viable also, to build independent AJDs for each individual microservice. I think the big question that I would ask myself, which way to go, which way to favor, is whether there is any data interchangeability or data overlap between the various microservices, right? If you have data overlap, I would go down the same theme of what we have with the Converged database. I would settle for one single source of truth when it comes to the data, right? You will see that later. I will talk briefly about a customer if I get to it, who was actually facing the issue of having, the same data in multiple layers in multiple databases because of the limitations of single purpose databases. So I would consider that the technical argument here is really, okay, is there data overlap or not? That aside, there might be legal restrictions or whatever when it comes to such an architecture, but there is no physical or technical limitation to choose either or.
That's great. Thank you very much. I really appreciate that. And I think, Julian, you had a comment maybe on the microservices. MongoDB, is that right?
Yes, but I think Hermann, I think Hermann answered the question, but basically it would also depend on the business requirements. If, for example, all the business services all the microservices are part of the same business application, for me, it sometimes might make sense to put everything in the same autonomous database. However, you might have business requirements like high availability, security, whatever. You might want to create several autonomous databases.
Yeah.
Okay, excellent.
Thank you, Julian. Definitely another criteria.
All right, so guys, so I'll keep this open. You can continue typing your questions there. So this is basically, again, the same links I showed at the beginning. I'm going to share that in chat again, in case you guys want to come back here. So you're also going to find the link to the recording, and with the recording, you're going to you guys are going to get the PDF and the links that are in the session as well. And final thoughts here. So we have 2 places where I post the recordings. They're going to go back to the original Learning Lounge, and also they're going to be part of the main blog there, in one of the blogs that we have for ADB Learning Lounge. Okay, so in there, I'm going to make sure that you guys see the links and all that and information, right, that we had for the session today. Okay, so next sessions we have basically we're going to have this same session tomorrow, and then next week we have an Apex on ADB. So the best practices on that, and then the last week of December for us is going to be the 19 and 20. We're going to talk about data safe, right, for security. So you guys can keep asking questions. I'm going to again stop sharing here. Again, thank you very much, Beda. Thank you, Herman. Thank you to Josh and also Julian for joining and answering questions. And I'll, again, leave this open. You guys can answer any questions that come up. And again, thank you. Really appreciate it. And I'll talk to you guys tomorrow then.
Sounds like a plan. Thanks, Marcus.
Thank you very much.